What are critical minerals?
So critical minerals are minerals and metals that have no viable substitutes, and they're at risk of supply chain disruptions.
Okay.
So we need critical minerals for renewable energy, things like nickel, lithium, cobalt, rare earth elements, principally for wind, solar and lithium-ion batteries.
And so those are necessary for renewable energy. Anything else that they're used for? Or?
Yeah, so we have a number of military applications for some of these, which is why another reason, sometimes they're called critical, but there's also a strategic minerals list that countries have. In the case of rare earth elements, these can be used for military applications as well. So countries really want these minerals.
And what about computers and things that I just imagine?
Absolutely. So
like
a lot of technological applications. So we need them obviously for AI, for quantum, for all the digital technology.
So critical minerals are important because they go into a lot of products, but what are some of the negative impacts?
So some of the negative impacts, lithium and the evapotranspiration process, you get a lot of toxins leaching into the soils and into the waterways. This can lead to negative impacts in terms of being absorbed into the human body, which can lead to liver and thyroid problems. So that's specific to lithium. A lot of toxins and hazardous waste from rare earth elements mining. With rare earth elements specifically, we're talking about the level of ionizing radiation. And so NGOs have documented the impacts of that radiation, for example, in processing rare earth elements in Malaysia, where the radiation levels have been well above the International Atomic Energy Agency's recommendations.
Okay.
So these are not good, right?
No.
In terms of hazardous waste and human health.
Yeah. And what kind of research do you do in this area of critical minerals?
So a lot of my research is really concerned about how we transition rapidly to renewable energy, considering the climate crisis that we're all increasingly experiencing. So we've got a very small window in order to be able to limit global warming to 2 degrees if we're lucky. We're on track for over 3.1 at this point, which means life as we know it is going to change rapidly within a very short period of time. And so when we were concerned about how that transition is playing out, we wanted to look at what we needed for the transition. And so one of the bright spots in meeting the Paris Agreement under the UNFCCC is actually our shift to wind and solar. Solar pretty much is outgunning everything else at the moment, and electric vehicles. So these are the two bright spots. And so how are we actually doing this? And I was really concerned with thinking about the fact that we need critical minerals, we need to extract from the earth in order to save the planet, or save humanity, really.
And that's your motivation for getting into this. And so what was your research involve?
So it's really looking at what the impacts of this renewables extractivism is, like what we're doing when we extract all of these critical minerals in terms of the environmental and social impacts. And so many countries have national legislation and regulations about how to minimise the environmental and social impact. But even if some countries do have those laws, they might not have the capacity. So if Indonesia's extracting nickel, or the Democratic Republic of Congo is extracting cobalt, and we're dependent on those minerals globally, what impact are we having at that local level?
Yeah, and how does Australia fit into this global situation?
So Australia is very lucky, lucky country, in terms of the number of minerals and metals that we actually have that we can extract. And so we are the world's largest producer of lithium in the world. We're the 3rd largest for cobalt, and we're the 4th largest for rare earth elements. And
so Australia is the largest producer of lithium, and so that's kind of a bit surprising.
It's super surprising. A lot of people don't talk about that story. And I think there's 2 things there. One is that lithium, in compared to what we traditionally export, your iron ore and coal, so much larger than the market for lithium. So that's one thing. The second thing is that most of the literature that looks at critical minerals globally really looks at the cobalt in the DRC because it's the world's largest. It's also the most fragile in terms of political violence and harms for people living in the DRC.
Yeah.
The second is that most of the literature looks at cobalt in the DRC and looks at lithium being produced in the lithium ion triangle in Latin America. So Chile is I think the second or the third largest producer of lithium in the world. And so it has very, very different lithium extraction process from Australia.
Okay.
And that has a significant environmental and
So
social.
how's it different, and why? Why is it having an impact?
Very, very different. So in Australia, it's hard rock mining, so we just dig it out of the ground. In Chile and in the lithium ion triangle, it's a process of evapotranspiration. So it's a chemical process that uses a significant amount of water. And this means that the environmental hazards are so much higher because the toxins from the process actually leach into the water, get into the food systems and the ecosystems, and can get into the human body.
Yeah, that doesn't sound very good. And so in South America, you talk about a triangle. Like, is it a few different, a big area that lithium's mined in?
Yeah, so it's primarily in Chile and Argentina. Bolivia has a significant amount of deposits as well, but has at this point chosen not to extract.
Okay, why is that?
So there's a couple of interesting things happening. So scholars talk about resource nationalism, and this is primarily, Australia is resource liberal, so we're all open markets. Not much going on in the way of Australian government owning mines.
Yep.
But in Latin America, we see a totally different story. And so Argentina is a little bit more like Australia, but places like Bolivia have nationalised, which means that basically there's some interesting arguments going on here, but they have decided that it's not beneficial to actually engage in mining of lithium. And so there's a couple of different things going on in that country, but it's just very, very different. And there's always the possibility that they will enter the market.
Yeah. And what communities are most impacted?
Well, quite often they're at the project site.
Yeah.
So this is where the extraction of the minerals is taking place, or at the production site where it's actually being produced into a state that's ready to go into the renewable energy. So most of this is being undertaken in developing countries. So I talked about the DRC for cobalt, nickel in Indonesia, rare earth elements in Malaysia and in China. There was a significant problem in the sort of 2010s where China tried to clean up its act in terms of rare earth elements that it was extracting. So shutting down a lot of mines because of the environmental and social impacts that they were creating, which caused an international incident because they forewarned Japan, which was importing a lot of rare earth elements from China, that there was going to be a cap on how much was being exported. And this was in the international media, was sort of touted as China purposefully seeking to restrict the amount of rare earth elements in the market for geopolitical purposes.
Okay. But they said it was to try and clean it up because it's poisoning lots of people.
Yeah.
And what about in the Australian context?
So the Australian context is interesting because we argue that we have some of the highest environmental and social standards in the world. And I think that is true when compared with developing countries. It is quite difficult, I think, to potentially process critical minerals here, which is what the current government would like us to do in terms of the Future Made in Australia Act, to have a higher value add rather than just digging and shipping, to digging, processing and shipping.
Yeah.
So we do have some quite high environmental standards. But we also know that there are very few benefits that are flowing to First Nations people in Australia, and this is comparatively quite poor with what other countries like Canada are doing.
And so First Nations people in Australia are the communities most likely to be living around these mines, or?
Yeah, so a recent study undertaken in Australia identified that I think it's about 57% of mines for the critical minerals mining of critical minerals actually in or near Indigenous people's lands. So at this point, it's how to have what they call better co-benefits for First Nations people to actually derive some sort of benefit from having their lands extracted.
Yeah. And so what's Canada doing better than Australia? What's the difference there?
So more upfront about the rights of First Nations people to be involved and engaged in the mining process and what those benefits should be. So scholars around the world are now starting to look at what the community benefit sharing agreements are and what communities are actually benefiting from. Traditionally, there's been a great power imbalance between a mining company and an Indigenous community in terms of what they can get from having their lands degraded.
And the what did you say?
Co-benefits.
Co-benefits agreements. How are they working in Australia?
We don't know.
Oh, okay.
So that's one of the things that we're trying to find out.
Yeah, okay.
A lot of these community benefit sharing agreements are confidential. So once communities sign them, they're actually not allowed to talk about them.
Which is problematic if you want to know if it's good or not.
That's right. And what other communities know that they can ask for.
Yes. If you're a student who's looking to study this area, what would you recommend?
So there's a number of things you can do. If you're interested in the mining process, you might be interested in geosciences or geography. If you're interested in trying to improve the application of mining, then you'd want to go into the hard sciences. But if you're interested in the environmental and social questions, and how to better regulate or try and find better policies or better ways to regulate mining, then you might want to look at social sciences, political sciences, and if you're like me and you're interested at the global level, international relations. So I work with teams from around the world: Chile, Argentina, Canada, another mining country, the United Kingdom. And you can do an undergraduate degree in social and political sciences, and honours. Honours is where you really get to get stuck into your own project. So it's 1 year in Australia where you can actually look at a specific mine, specific mineral, specific regulation, and what we can do better. From there, if that itch is still there about trying to find better ways to address the climate crisis, then that would be doing a PhD.
What is the most valuable, going into the hard science area or the social science area?
So they're both really valuable. So when we
Controversial question.
When we talked about the fact that there were no viable substitutes, this is something the sciences really are working on very hard. So how we can find alternatives to lithium rather than using lithium-ion batteries in EVs, and that's really ongoing. If you want to talk about how best to regulate, clearly it's helpful to know what's going on in terms of what is possible, but it also comes down to how to broker political solutions. And that at the domestic level is political science, at the international level is international relations. So most of the climate crisis, it's not because we don't have the technology, it's because we can't broker solutions. And that's negotiation, that's politics. If you have any questions, just leave a comment below. And if you'd like to know more, just take a look at the links in the description.